burning out.
Check. Good evening, everyone. It's nice meeting you to all of you. Um, my name is Tamizhvendan. I'm working as a lead consultant in a startup called Agiro, and I'm a pragmatic, passionate, and polyglot programmer. And those two names, passionate and pragmatic, are actually named after two great books which I read, which changed my life for the better. Pragmatic programmer and passionate programmer, like great books. And I recently self-published my first book called F-Sharp Apply, which is all about how to apply functional programming language to develop web applications. That's a little bit of background about me. This talk is all around state and managing state. So I'm sure like you all designed applications where state is actually the integral part. We use database to maintain that or file or some medium where we persist the state. And the way we manage the state actually has a profound impact on the way we architect the solution. So when develop solutions around managing the state, do we really need to manage the state in the first place? And there are a lot of architectural patterns which talks around this area. And one of the most interesting topic around this pattern is called event sourcing, which you are going to see in this presentation. And there is another concept called common query responsibility separation, which is called as CQRS, which is both related to each other. So this particular talk, we are going to address these two concepts from the functional programming perspective. Like, how many of you already know functional programming? Good, that's great. What is the language that you are working?
F-sharp.
F-sharp, that's great. What about you? JavaScript. Great. It's really nice to know another F-sharp person over here. Great. So, there is one of the very famous Twitter around tweet from Michael Feathers, one of my favorite programmer. He talks about what is the difference between object-oriented programming and functional programming language. The tweet summarize actually pretty much the entire talk that I'm going to give. So he talks like object-oriented makes code understandable by encapsulating the moving parts, whereas in functional programming makes the code understandable by minimizing the moving parts. By moving parts, he means the state of an application. So in this task, like we are going to have a relook at how we currently doing state management and what would be another alternative. In this talk, I am going to use application. Instead of talking more theoretically, we are going to see almost a real application. And from the typical object-oriented perspective, how do we normally develop this kind of system from the state perspective? And I'm going to dissect from there. I'm going to include functional programming in that perspective. Okay, and okay, I just want to give a credit to this CQRS.mu, which is actually the company where I saw this example as I'm going to show in F-sharp. Okay, this is a kind of cafe app where you actually visiting a cafe and you can take any table and just clicking the table. Once you click the take, like it is waiting for the order. The order taker probably has this screen, and I'm just ordering a salad and Coke, and then I'm just placing the order. Once I place the order, the table it becomes in service. That means the table is currently being serviced. And typically, like the food that you order has to be prepared and then it has to be serviced. So the food that has to be prepared will come under chef. The chef probably seeing this screen, and the waiter, the drinks which you order can be served immediately. So waiter will be having this. So I'm just marking this as served. So the Coke has been serviced. and now the chef has prepared the salad meanwhile, so he also marking it's prepared. So as the salad has been prepared, it has to be served. So the waiter now just picks the salad and mark it as served. Now the order has been completed. So now it is up to the cashier to get the cash, and he got the cash from the particular visitor, and he marked that paid. And if you come back, the table status again open. Now another visitor can take the tab. Okay, that's the application that we are going to look at in this entire talk. So, okay. So before dig deep into the topic, let's see how we develop in a old school backend data store, which is again imperative way of modeling the data. So I just took an example from NoSQL. It can be a relational database also. I'm just picking because it's much simpler to represent this particular thing in NoSQL. So what we typically have for each state, I'm just taking table out. There are a lot of screens in the application that I show. I'm just showing only table. So for each state, probably take or waiting for order or in service, typically we will be having something called tables and ID and in status which will be changing like available, waiting for order and inserts. So this is how we mutate the state and we maintain it in the first place. Okay. Let's look at this particular problem from a different perspective. What I'm actually going to introduce is time. So the state is very clean at the instant of time called T0. At T1, it received a command called open tab. I'm using the word tab which actually tracks the workflow. Like say the visitor takes a table and he places some order, the order served. The entire workflow is being I know we are using the term called tab to track everything. So at the instance T1, we receive the command open this tab. And after some time we are receiving place order. So it goes on. So if you, from the database perspective, what we are actually doing is at different instance of time, we are mutating that particular property of a NoSQL document. It can be, in case of a relational store, we will be modifying a particular column in a table. But if you see, actually state is a transient factor, which will evolve over the period of time. So we can derive the application that we see as like this. For example, when the application was started, it is in closed tab. It receives the command open tab, it moves to the opened tab state. Then it receives place order command and it moves to the next state, which is called placed order. Order has been placed. Likewise, there are a lot of commands like you can serve a drink. When the order is in progress, typically we serve drink and maybe the food which we ordered might be prepared. So it receives the command and moves to the next state called order in progress. Likewise, each and every state receives some command pertaining to that particular state and move to the next state. So this is nothing but what we call a state transition diagram. So we transition the state in response to the command which is coming from the external world. So we can generalize say something like state X upon receiving command moves to state Y. So what we can do, we can define a function for this. Let's name it as evolve. Evolve is a function that takes a state and a command and creates a new state. Clear and simple, like a mathematical function, you take two numbers and the output would be a different number. Likewise, evolve is a function which takes a state and a command and generates a new state. The command is actually coming from the external world. State, where it is actually from. In a typical world, it is actually come from a database. We actually fetch the particular state from the database and then we call this function providing the state. This from now on, we are going to derive that particular state. Much like a mathematical theorem, I am just going to say hence proved after some time. Okay, so we started with this initial state. We all know a closed tab. The tab is closed. It receives a command called open tab and it moves to open the tab state. from this particular instance of time, this is happened. But how does the outside world know? That's where we are going to introduce a new term called event. When this particular state transition happened, there is an event called tab open emitted. This particular event has everything that actually happened. Just define this as a function. Execute is actually a function over here. Again, it's similar to the same. It takes a state and also a command from the outside world, and it creates events which represent what actually happened over there. So if you think of the same thing, it is the state transition diagram that we see before. Every state, when doing the transition, it emitted some events. For example, from placed order to order in progress, the drink has been served. So that is the event which happened and we are emitting that. That event has everything. For example, when a drink has been served, it will contain what is the drink ID which is served, to whom it has been served, what is the table to which it is served. All the information pertaining to the event is part of the event itself. So, I just want to conclude with this particular thing. Like, events are nothing but facts of your system. You cannot deny. For example, you take the bank statement. It starts with 0. Say salary got credited. Say 1 lakh. What would be the new state? Your account balance is 1 lakh rupees. And after some time, probably an EMI deducted. Say 15,000. So your account balance would be 85,000. There, salary credited, EMI deducted. All these things are nothing but events. By capturing these events, like plus 1 lakh, minus 15,000, we can generate state out of it. And that's what this particular function, apply. Apply takes a state and also an event and it creates a new state. Again, it is a function. So, what we want to do over here, when the command got executed, instead of storing the end state, what we're going to persist is the events that are getting emitted. So, just think like a up and only log stores. Like the tab opened, the order placed, drink served, food prepared, food has been served, drink served. All these things which has happened in a workflow has been persisted in an up and only data store. There are databases like Datomic or Event Store. This database supports this kind of. There are even Elasticsearch also to support this to a certain extent. So I am not going into the database side here. It can be any database. Even you can write any this kind of system on top of MongoDB also. So, but basically the logic over here is we are persisting in a database in an up and only format. So the new event always appended to the end. So we started with this function apply, and we know what is the initial state, and let's take an workflow that what I showcased in the demo. Like I captured all the events in my database. So what we want to do? We take the initial state and the first event tab open and apply this function and create a new state. That is, we started with closed tab, which is the initial state, and applied the event tab open. Now we have the new state, open the tab. The next step, now the state is open the tab. We take the next event, order placed, and apply that event. We got the new state called placed order. Likewise, if we take all the things and apply the subsequent event, we will eventually move to the next state, that what we saw in the state transition diagram, which is what we call a fold operation. It is much like a summation. Say for example, you have an array, say 1 to 5, and you know the initial state which is 0. You apply the plus operation. So you take 0, take first the item which is called 1, and you apply the plus function. You will end up with 1. Then you take 1 and take the next event from the next object from the array, which is 2. Apply the plus function. You will get 3. Likewise, we can scan to the entire array and we can reduce that to a single value, which is called fold operation. Okay, what we do, we take the fold, apply the function with the initial state is known, which is passed from that state, and we take the past events and we compute the state. And at this point of time, you may have some question around performance. There may be a lot of events. Do we need to go through all the events to compute my state? We will address that a little later. Okay. So we started with this. We want to know how we are going to get the state. And in the process of deriving it, we come out with three different functions. Execute as a function which takes a state, a command, and returns the events associated with that particular command. Then we define a function called apply, which takes a state and an event and generate a new state. And then we come out with a function called compute state, which takes the initial state and all the past events happen, and then coming out with the actual state. So what we are going to do, we are going to use these three functions and going to rewrite that evolve function from state to past events. So what we are going to do, if you see from the signature perspective, we change state to event list, and in the evolve function, we compute the state by calling the compute state function with the initial state, and then we execute the state with the command, and then we will be returning the new events list. So we started with this evolve function, and we ended with this function. So what actually the difference here is, in the first function, we take a state and a command and returns a new state. In the next, the derived version of evolve function, we have an event list, command, and event list. Basically, the current state is nothing but a left fold of past events. This is called event sourcing, and it has been introduced by the great person called Geek. Okay, he is the one who actually coined this term event sourcing. So that is why, if you have seen the very first slide, I have this little tiny functions. Current state equal to fold L of past events and the initial state. Okay. Now we derive state is nothing but a fold operation of the past events happen in the system. Great. So now we saw state. Now it's time to, when we want to put this into a real application, we need to handle the command from the outside world. Correct? So how do we do it? So let's take this evolve function, and it requires it command to execute, and it also requires the past events in the system. So what I am going to define two different functions. A function called get table ID, which takes the command and returns the integer, which is nothing but the ID of a table. Say for example, open tab is a command. That particular command is going to contain what is the table ID it has to open. If you say something like a place order, that place order command has to also contain a table ID to which the order has to be placed. So this particular function is going to look into the data structure of a command and going to take the table ID out of it. And get past events is another function which is going to take the table ID, which is an integer, and it is going to talk to the database and going to get the event list. Okay, this function is not pure function because it is going to talk to an external system to get the result. So it may return an error. For the simplicity, I am just ignoring that fact. Let us assume that everything is good. So it returns the actual events stored in the database. So we can create the handle command, the command which takes from the external world. We call this function like get table ID of this function, and then we this pipeline operator. Oops. Okay. This pipeline operator is similar to what we have in Unix, like the output of the particular thing will be input of the next thing and so on. So we get the table ID from the command and then we pass it to the past events, get past events function. So we will get past events. And once we got the past events, we already have a evolve function which takes the past events and a command. So this is how we handle commands. So this command is as a business term right now. In order to expose this as a web API, you need another function, which I call it as command handler, which takes a HTTP request and an HTTP response. This is also another function. So this function, what we're going to do, we're going to take the command, like which is something like we are going to look into the JSON structure inside the HTTP request which is posted and going to convert that to a command and then call the handle command function and you will get new events. And you will save the events on this function save events which saves the new events which is getting generated and return an OK response. We will come to the error handling later point of the slide. Okay. So this is how we will be addressing all the commands. Open tab, close tab, whatever command which is coming from the external system, we will be handling in this way. So this screen, like we saw the commands so far, but like this kind of display that we are showing in the screen is actually some data has to come from the database. There is no alternative for that. So this particular information has to be stored somewhere so that it should be available for the or any front end, a web or a desktop application to show. Which we what we call as queries, which is nothing but like you just talk to the backend system, hey, show me what are what is the status of a table. Now from the chef's perspective, what are the food he has to prepare. And cashier from perspective like what is the amount he has to get from that particular visitor. So all this information has to be retrieved from some sort of a store. And it has to be queried from the backend. So far what we have seen is all around commands and state. So how this queries has been implemented in the old school backend implementation. This I am going back to the first slide where we have shown that NoSQL format. We typically mutate this particular document in commands and we fetch this same document during queries. You got what I am telling? Like we have a document which whenever we receive any external command from outside world, we mutate that particular document. And when it comes to get some sort of information out of the document, we query the same document model. Okay? This is one of the common pattern that we do most of the applications, right? So it is okay, but there are cases where we get into a kind of a corner where we need to do some sort of optimization to, like, say for example, if we do some sort of optimization for reading it, then our write performance will go away. Or we may need to make compromise on something on write. So if write is so important to us, then we compromise on read. Or what we do in relational database, we create views for everything or store procedure for everything. Right? So this is how we do the data modeling in an imperative data model. So basically, what we need to do over here is we need to apply the single responsibility principle. Commands are separate and queries are separate, which is what we call as a command query responsibility separation. So back to our example. How do you handle queries? So we already derived this particular point, like when a state receives a command, it emits an event and moves to the next state. This is what we have seen so far. So what we are going to do, we are going to publish this event to a message queue. I am assuming the application that I am showing here is running on different processes. Probably if both the right side as well as the read side runs on the same process, you may not need a message queue. Probably you can use an in-memory message queue or something like that. So what you are going to do, you are going to publish whatever event which is emitted by the command into any message queue like Kafka or RabbitMQ or something like that. So there will be a listener who is nothing but another client who is going to listen to this message queue and populate the database. And once the database got populated, your API backend is going to talk to the server, pull the data, and show it in the UI. Which is what we call as read model projection. It takes an event, projects the value out of it, and persists in a data store. The advantage of this particular way of thinking of solving a problem. Now, the query part is totally decoupled from the command side. So what you can do, you can create a new client called WebSocket client, which interactively pushes the update to the front end. Now your system is reactive. All you need is just another claim. And in this process, the app that you developed went very well. There are a lot of data kicks in, and you want to do some sort of data analytics to it. How do you extend? Very simple. Just create another claim. This line I'm just calling as data claims, data analytics claim, which again listen to the message to, and it's going to populate its own database. Say for example, the database that you are using, say MongoDB, which may be useful in your the transaction application that you are developing. It may not be the right database for doing data analytics. Probably you may store one store that into Cassandra or some any database. So what that particular claim is going to do, it's going to take the event and going to populate its own database. And once it populates, the data analytics, the data scientist comes into the picture and he solves the problem. And the command is actually going to come from the web friend, and it's going to again goes back to the workflow that we defined before, which is nothing but unidirectional data flow. And this architecture has been inspired in the creation of Flex, React Flex, and Redux actually uses this. This is by in the JavaScript world. So this is how the event got projected and persisted. The data has been persisted and been queried in the thread. So let's take the same the table example. Like the table has to undergo 3 different states. So what? It is the initial state. Upon receiving tab open, the tab opened event has the ID, and after fetching the ID from that event, we are going to change that to waiting for order. Because we know when a tab has been opened, it is moving from a closed state to a next state. Then when the order has been placed, you just need to listen to the command, get the table ID, change that to in service, and it goes on. Like when the order has been served, it again goes back to this. So each read model listens to only those events which is pertaining to the particular read model. Here the read model is the table. In terms of chef or maybe waiter, he will be listening to his own event. Probably order placed event is what chef is interested in. Chef is not interested in listening to some other events. So he will be only interested in order placed. So he will look at what are the food has been ordered. He takes the food from the order and he started preparing. So all the read models will listen to only those events and populate its own kind of database or data model, and eventually they will do the work. So now come to the interesting point. Like in a real world, everything is not perfect. So maybe the user may post an invalid command, the fetching events from the database may fail, or saving events may fail. So the error is something that we cannot avoid. So what we are going to do? We are going to model a data called result. It is a discriminated union type. Basically, you can think of like a choice type. The result can be either a success or an error. So success, it is a generic type. Success can take the success value, and error can take an error value. This particular type represents the result of an operation. If it is succeed, this value will be populated. If it is error, the second error value will be populated. So with this particular type, let's revisit the existing functions. We have already execute function, evolve function, and handle command. So what it is going to do? I'm just taking an example here. So the execute function right now receives a command open tab. When the execute open tab command receives, the expected existing state would be it should be closed. So when it is closed, what we say, we return it as success, and the event is tab open. In case the state is something different, which what is kind of like underscore is it matches every other state, much like the default statement in a switch case. So we return an error saying that the tab has been already opened. So now the signature of the execute function changes from event list to a result of either event or string. Now, it is just accordingly we will be changing the signature of eval function. I'm not getting into the detail here. I'm just changing the signature. So subsequently the function body will change to adopt this particular data model. So the handle command also, instead of returning an event list, it will be returning a result of event list or a string. Cool. So we already have the function called HTTP the command handler. So again, Now, the handle command in the previous case just always return the new events. Here, this handle command it is going to return either success or error. In case if it is success, we are going to save the events and return OK response. If it is an error, we know what is the error message is, and we are just going to return a bad request. So in that way, the end user will know whether he is posting a right comment or a wrong comment. Same way, we can extend this particular error handling to other comments, like other system. Like here, I'm just save events is always succeeding. Probably, if you want to extend that to add error handling, you can do it in a similar way. And if you are interested in how to model error handling in a functional programming language, there is a great blog post series by Scott. Is this web shop for funandprofit.com. Like this has a lot of great tutorials on web shop and as well as functional programming side. So he talks about this concept is actually called railway oriented programming, where you model error in such a way that it has some sort of a wrapper type around it, and all the subsequent functions take that wrapper function and act accordingly. If it is an error, it handles the error. If it is a success, it handles the success. Cool. So let's come back to the initial thing that we discussed, like the performance. Like how one in order to compute the state, we need to go through all the events and then reduce it to compute a small value. I'm sure that performance is a factor. Okay. So how do you overcome this particular problem? How many of you do Git rebase? Okay. Now the tough questions. So basically, what we do is we squash all the history and we start from zero. The same thing what we call as snapshots. And when it comes to performance, always keep in mind we don't do any premature optimization or something like that. So when you feel the performance is degrade on the command side, just do the snapshots. It is much like the bank statement again. So bank, I'm not sure how many months they maintain the history of the bank statements. So say example all you are interested in last 2 years. So once the 2 years has been gone over, you take the balance in that particular time, and that will be your initial balance. Say for example, they are going to squash all the history. They will be starting from whatever balance that you are having right now. Then that is going to be your initial balance rather than starting from zero. So by doing this, we can improve the performance on the command side. And another thing which will come in the real world is around parallel update. We cannot expect it is unsequential. When you run it in a system there will be a lot of concurrent requests will come into the system. How do we handle from the event sourcing perspective? Event sourcing is not a kind of a solution which magically solves concurrency. We need to still handle it, and the easiest way of handling it doing optimistic logging. For example, each event will have some sort of a serial number. It starts from 0, 1 or something. This model here, it can be any serial event which will track. Say for example, if a new event comes which is not in the adders there, that is mean that that particular thing is there is some sort of concurrent event is happening. So we are doing some optimistic logging here. Fine. And things to consider when we are implementing your system using this kind of architecture. Like everything in software engineering, the solution which I propose is not a silver bullet. It is not going to solve all your problems. So apply your based on your context, based on the situation, based on deliverables, deadlines, and all those things are really matters when it comes to real world development. So think it as an idea and apply only where it makes sense. And one of the common anti-pattern around this event sourcing is developing the entire system based on event sourcing is an anti-pattern. It has to be part of a thing. They're part of it. Actually, what we say is they are not top-level architectures. Say, for example, you are working on a CRUD-based applications, and say you want to change that particular form has 4 fields, say first name, last name, email, or phone number. If you apply event sourcing there, what will end up with? First name changed, last name changed, email changed, or phone number changed. Yeah, if your business domain requires all the events happening on the system has to be captured, that makes sense. But if you are working on only a common thread system, don't go for event sourcing. So apply your common sense as well as the context, the problem before you solve it. And now my favorite F shop site come. So actually it's interesting. I was looking around Carpet Stake Radar and I found this particular thing. It's quite interesting and it is way back 2012 where it was mentioned like the developers are trying to achieve explicit business logic with an application may opt to express the domain in F sharp. This is interesting and majority of the plumbing code in C sharp. It is itself is a testimonial of how F sharp is. Like F sharp, as from the language perspective, it has the goodness from Python, Haskell, to some extent Clojure. Basically, it takes the best of the languages and it is created, what can I say, is one of the pleasure to work with. And the source code that I'm going to show is there in my GitHub repo. And it is actually the whatever I'm talking right now is nothing but the last chapter of my book, Web Shop Public. I will be posting these slides in a slide share. So I will be sharing with Cartos Geek channel so you can get that. Okay, so let's see some sort of F sharp code and how this has been implemented. Okay, so how much time do we have? 10 minutes. Good. The first interesting thing is I'm using Atom Editor. I'm not using Visual Studio. One of the common misconceptions around F sharp is it is from Microsoft.NET. So everybody will have a little comprehension or something like that around picking this particular language. F sharp is a cross-platform language, completely supported under Mono as well as the new .NET Core. And we have an excellent plugin called Ionite, which supports editors like Atom, Visual Code. Even we have F sharp binding for Emacs. So you don't need to come out from your favorite editor. Cool. So let's start from the domain. So is it visible from there? Okay, fine. If you have a hard time, seeing that, probably you can come up front. Okay. Sorry. I can do. Yeah. I believe it should be visible now. Good. So I'm just modeling tab. This is the ID. It is a unique ID and table number where the tab has been pointing to. And item. This is nothing but the menu number, the price, and the name of the item. I'm modeling a food. These are nothing but I'm just modeling. A payment will have which tab it is being and what is the amount of that particular payment. I'm just modeling the data pertaining to the cafe app domain. Once we defined this is an order. Order will have a list of food, a list of drinks, and which tab that particular order belongs to. So when the order is in progress, we will be having the real order which is placed. What are the drinks has been served so far? What are the drinks has to serve? And what are the food has been prepared? Sorry. And this is now we model the domain. Next comes the interesting part. Events. Single page. Just 10 lines or even less than that. We model the entire event that we are seeing so far. This is one of the most beautiful aspects of F sharp. You can take your model and create an equivalent representation of that particular model in F sharp using their F sharp type system is very, very pleasure to work with. And that's why in the radar it's like the people use F sharp to model the business domain and then use C sharp for the plumbing code. See, like we have all the events and associated data. For example, tab open has tab, which is nothing but the data which goes along with that event. Order placed has order. Drink served has the drink, and the GOD is nothing but the tab to which the drink has been served. And comments, basically in event sourcing, comments represents a present tense, open tab, kind of place order, serve drink. Events represent the past tense of it. Tab open, order placed, something. I just want you to think for a moment. How do you model this in C# or in Java? It will be like base class event, public class tab open inherits event, public class order placed inherits event. There is no offense here, but from the developer perspective, just see how much code you need to write to model this particular domain. Okay, I actually from C# and Java background, so those developers don't take it in a wrong way. I'm just telling that there can be a better way to solve the same problem. Okay, cool. So let's look at functions. So we saw a evolve function. So this is how the function looks. This is a pattern matching what we call. Like I'm just executing the command, and if it is success, I'm just going to do the fold operation and then getting that. So there are a lot of other things like since shortage of time, I'm just moving away. So if you want to really look at the code, it is there in GitHub. Okay, and the interesting aspect of F#, there is a concept called the type providers. Okay. Good. So when we model endpoint, HTTP endpoint, typically we do model binding. Like we take a JSON response and we do modeling with the underlying class or whatever you want in the particular language. So here the request to place an order will have a tab ID and food menu numbers and drink menu numbers. This is a sample request for placing an order. So let me click. Okay. Let me take this serve drink because I'm actually doing some error handling there, so it will be a much interesting one. So serve drink will take a tab and a menu number. So here the equivalent object will be a class with tab ID and a menu number. Okay. Now I'm just changing the JSON structure. Instead of menu number, I'm just putting number. Have you noticed? I just changed the JSON structure. My code does not compile because it's showing a compiler error. It says that the field menu number is not available. If you are in, just think of in C# ASP.NET MVC or in Java, like we need to do this binding explicitly. This type provider automatically infers the data from the end data, and it now if I instead of menu number, if I change that to number, even I am getting intelligence. See number. My code compiles. It's the magic of type providers. So this is also a great aspect, and there is a library called Suave. This is a very lightweight web server. You can express your HTTP endpoint just like that, like just using now, without any segments. This is my path, much like Sinatra from Ruby. Like you just define your path, pipe everything into the function, and then do and then compose. Great thing. And another great aspect of F# is around its ecosystem. It's driven completely by the F# community, which is very young, vibrant, and there are a lot of great people are working on that. One of the cool tool available in F# is called Fake. Much Drake, like Drake is faking. It's nothing but ability to build your products. And I'm just showing a sample script. I'm just defining targets. All the targets are checked at compile time. So if you do a mess up with your build script, you will get a compiler error here. So I'm just building an app, I'm just building the test, I'm running the test. The interesting aspect is it integrates with your client. This particular app that you saw in that presentation, it's coming like is using front-end React Redux in the front-end. So this particular target uses npm, run npm install and run npm build, all inside my F# build tool. And then all I need to do is just define the dependencies. This is like a DSL, which is completely tested by your compiler. So if it compiles, it eventually works. So that is around the fake side. So we lost 2 more minutes. I just quickly run through. You can integrate this with Docker with the help of Mono. It's using Mono right now. It can be extended to .NET Core. Okay. So I'm just a simple Docker file which compiles using the build script that I shown. And once it compiles, it exposes and runs that application which we built under using Mono. Okay. So now it is in Docker. What we can do? We can do continuous deployment. So I actually there is a Travis XML there. So what we do, whenever I push the changes to GitHub, Travis CA will do the integration. It will run my test and everything. If it is succeed, it push the new image to the it will signal Docker Hub. Docker Hub will create a new image. Once the Docker new image got written, I can create another webhook which will let Google Cloud know, Docker Cloud know there is a new image. So what does it do? It again redeploy the existing service in the new image. Completely based on the typical open source stack. This is one of the common misconceptions is around it's Microsoft stack or something, but it's completely open source right now. Even you can go and change the F-sharp compiler. There are a lot of pull requests getting accepted. It's completely driven by the F-sharp community. Okay. Well, that's all about my presentation. Coming Saturday, I'm actually running Chennai F-sharp user group meet. So coming Saturday, we are having a hack on F-sharp where I'm going to help you around getting started with F-sharp by using functional principles. So if you are interested, check out Chennai F-sharp user group. That's it. Thank you. If you have any questions, please catch up me during the break, and I'm very happy to answer you.